Last time, we looked inside the atom and found electrons whizzing around the outside. Now, almost everything you can see is made of atoms joined together. Water, air, this table, you. So the big question is, why do atoms join up at all? What makes them hold hands? The answer is hidden in those outer electrons. You see, an atom really cares about one thing: its outermost ring of electrons, and it is happiest when that ring is completely full. Here is what I mean. When an atom's outer ring has an empty gap, the atom is restless. Think of it like a ball perched at the top of a hill, full of energy, wanting to roll down. But when that ring gets completely filled, the atom relaxes. It settles down, calm and content, like the ball rolling into a cozy valley below. And do you remember our energy season? Things always drift toward the lower, calmer state. So atoms will do almost anything to fill that outer ring. And there are two clever ways they do it. The first way is to share. Watch these two atoms. Neither one has a full ring on its own. But if they snuggle up close and share a pair of electrons right between them, then that shared pair counts for both atoms at the same time. And just like that, both of them have a full ring and both are content. Sharing electrons like this is called a covalent bond. It is exactly how two hydrogen atoms grab onto each other. The second way is even more dramatic. Instead of sharing, one atom simply gives an electron away. Let me show you my favorite example. Here is a sodium atom, which has just one lonely electron in its outer ring. And here is a chlorine atom, which is just one electron short of being full. Well, that is easy. Sodium simply hands its spare electron over to chlorine. Now both of them have full, happy rings. But watch what happens next. By giving away an electron, the sodium atom is now missing a minus charge, so it has become positive plus. And the chlorine, which gained an electron, has become negative minus. And what did we learn about opposite charges? They pull toward each other. So the plus sodium and the minus chlorine snap together and hold on tight. This kind of bond is called ionic. And this exact pairing, sodium and chlorine, is something you sprinkle on your food every day. It is ordinary table salt. So let us clear up a big misunderstanding. A chemical bond is not glue. Atoms are not simply stuck together or just touching. Every single bond is really about electrons being shared or being traded, so that both atoms can reach that calm, full, low-energy state. Bonds are the pull of atoms toward peace and quiet. So here is how the whole world gets built. Atoms want a full outer ring because a full ring means lower energy, calm and settled. And they fill it in two ways, by sharing electrons or by trading them. Every bit of stuff around you is atoms holding hands in one of these ways. You now know how everything is assembled. Now here is a thought. If atoms can join up by sharing and trading electrons, then they can also let go and swap partners and join up in brand new ways. And that, my friends, is what we call a chemical reaction. When wood burns, or iron rusts, or a cake bakes, atoms are simply changing partners. But here is the astonishing thing. In all that changing, not a single atom is ever created, and not a single one is ever destroyed, even when something seems to vanish in flames. How can that be? That is our next adventure. See you there.